Welcome to the video on compound angle identities. So here are all of our compound angle identities. A compound angle identity is useful when you have an angle that isn't on our unit circle but can be split into angles that are on the unit circle. So 165 degrees, for example, isn't on our unit circle, but you can break that into 45 degrees and 120 degrees. Or you could break that into 30 degrees and 135 degrees. Or any combination that will add up to 165, where both of the other numbers are on your unit circle. So our sine of a plus b equals our sine of a times our cosine of b plus our cosine of a times our sine of b. Sine of a minus b equals sine of a times cosine b minus cosine of a times sine of b. Cosine of a plus b equals cosine of a times cosine of b minus sine of a times sine of b. Cosine of a minus b equals cosine of a times cosine of b plus sine of a times sine of b. Tangent of a plus b equals tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. Tangent of a minus b equals tangent of a minus tangent of b over 1 plus tangent of a times tangent of b. Our sine of a plus b times sine of a minus b equals sine squared a minus sine squared b, and it also equals cosine squared b minus cosine squared a. And cosine of a plus b times cosine of a minus b equals cosine squared a minus sine squared a minus sine squared b, or cosine squared b minus sine squared a. So these are really important identities to memorize and will be especially important when you're solving things by hand. So we can use our compound angle identities to derive our double angle identities. So here is our double angle identity that sine of 2x equals 2 sine x cosine of x. So our compound identity for sine is that sine of a plus b equals sine a cosine b plus cosine a sine b. For our double angle, we have the same angle, so we can call them both a. So we have sine of a plus a is sine of a cosine of a plus cosine of a sine of a. So those two would be the same things, so we could combine them together because they'd be a like term. So we get sine of 2a equals 2 sine a cosine of a, which is our double angle identity. For our cosine of 2x, that equals cosine squared x minus sine squared x, which equals 1 minus 2 sine squared x, which equals 2 cosine squared x plus 1. So our cosine of a plus b equals cosine of a cosine of b minus sine a sine b. So if we have the same angle, our cosine of a plus a is our cosine a minus sine a, which turns into cosine of 2a equals cosine squared a minus sine squared a. So that is our first part of our double angle identity there. And then we can substitute 1 minus sine squared of a for cosine squared a, which simplifies to our 1 minus 2 sine squared a, which is our second part. And then we can simplify from here to here and plug in 1 minus cosine squared a for sine squared a. And that's where we get our 2 cosine squared of a plus 1, which is the third part of our equality for our double angle identity for cosine. Finally, we can derive our double angle identity for tangent. So this is a new double angle identity that we haven't talked about in any of the previous videos. But our tangent of a plus b equals tan a plus tan b over 1 minus tan a tan b. And then if we put the same angle in, we'll get tangent of a plus tangent of a over 1 minus tangent of a times tangent a. So our tangent of 2a is 2 tangent of a over 1 minus tangent squared of a, which is our double angle identity here. So here we have our first IB practice question. It says find the exact value of tangent of 75 degrees. So we don't know our tangent of 75 degrees because it's not on our unit circle. So we want to split that into two angles that are on our unit circle. So on our unit circle, we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. So 75 is going to be the sum of 30 and 45. So we're going to do the tangent of 30 degrees plus 45 degrees. So our compound angle identity for tangent says that the tangent of a plus b equals our tangent of a plus the tangent of b over 1 minus tangent of a times tangent of b. So this would be the tangent of 30 plus the tangent of 45 over 1 minus the tangent of 30 times the tangent of 45. So we need to figure out our tangent of 30 degrees and our tangent of 45 degrees. So our tangent is equal to our sine over our cosine. So if we use our left-hand trick, our sine of 30 is square root of 3 over 2, and our cosine of 30 is 1/2. So this simplifies to show us that the tangent of 30 is square root of 3. For tangent of 45, we'll have sine of 45 degrees over cosine of 45 degrees, which is going to be root 2 over 2 over root 2 over 2, which just simplifies to 1. So now we can go ahead and simplify this part. So this is going to equal our tangent of 30, which is square root 3, plus our tangent of 45, which is 1, over 1 minus our tangent of 30 times our tangent of 45. So we have square root of 3 plus 1 over 1 minus the square root of 3. We can't have a radical in the denominator, so we're going to multiply by the conjugate. So we'll multiply by 1 plus the square root of 3. And we'll do that on the top and bottom. So our denominator here will become 1 plus the square root of 3 minus the square root of 3. So the square root of 3 will go away. And then we have negative square root 3 times positive square root 3, which would give us minus 3. And then our numerator would become the square root of 3 plus 3 plus 1 plus square root 3. So this equals 4 plus 2 root 3 over negative 2, which we can divide everything here by 2. And that gives us negative 2 plus the square root of 3. So we want to make sure that our sign is correct, like it's positive or negative if it needs to be. So our tangent of 75 degrees would be in quadrant 1. And in quadrant 1, everything is positive. With our all students take calculus, all of them are positive in our first quadrant. So our tangent should be positive. So we're going to do 2 plus the square root of 3. We're going to get rid of that negative. So our tangent of 75 degrees equals 2 plus the square root of 3. And that's your answer. Now we have our second IB practice question, which says find the sine of 11 pi over 12 times the cosine of pi over 12. So we're going to want to figure out which two angles can add or subtract together to equal these angles, because we don't know how to do pi over 12 or anything divided by 12 with our hand trick. So 11 pi over 12 on our unit circle is going to be pi over 12 away from pi. So this angle here is pi over 12, which is also 15 degrees. So the angle we're looking at is 11 pi over 12. And if it's easier to think about it in degrees, we can convert to degrees by multiplying by 180 over pi. Our pi's can cancel, and then our 12 and 180 can simplify to 1 and 15. So we have 11 times 15, which is 165 degrees. So this is going to be 45 degrees plus 120 degrees. So 45 degrees is pi over 4, and 120 degrees, we can convert back to radians by multiplying it by pi over 180. We can divide each by 60 to get 2 pi over 3. So this is 2 pi over 3. So we have the sine of pi over 4 plus 2 pi over 3 times the cosine of pi over 12. So that's going to be this angle here, which is 15 degrees. So 15 degrees is going to be our 45 degrees minus 30 degrees. So pi over 4 minus pi over 6. So our sine of pi over 4 plus 2 pi over 3 equals, we'll use our compound angle identity. So it's going to be sine of pi over 4 cosine of 2 pi over 3 plus sine of 2 pi over 3 cosine of pi over 4. Our sine of pi over 4 is root 2 over 2. Our cosine of 2 pi over 3 is going to be negative because it's on this side. So it'll be negative 1/2. Plus our sine of 2 pi over 3, which is going to be positive because it's a positive y value, and that'll be root 3 over 2, times our cosine of pi over 4, which is root 2 over 2. So when we multiply, we'll get negative root 2 over 4 plus square root of 6 over 4. So that's root 6 minus root 2 over 4. So now that we have our sine of this, we need to find our cosine as well. So our cosine of pi over 4 minus pi over 6 equals our cosine of pi over 4 times our cosine of pi over 6 plus our sine of pi over 4 times our sine of pi over 6. Our cosine of pi over 4 is root 2 over 2. Our cosine of pi over 6 is root 3 over 2. Plus our sine of pi over 4, which is root 2 over 2, times our sine of pi over 6, which is 1/2. So this is going to equal square root 6 over 4 plus square root 2 over 4, which equals square root 6 plus square root 2 over 4. So now we need to multiply these two because we have our sine times our cosine. So this is going to equal square root 6 minus square root 2 over 4 times square root 6 plus square root 2 over 4. So square root 6 times square root 6 is 6. And then we'll have square root 6 times positive square root 2 and square root 6 times negative root 2. So those will cancel each other out. Negative square root 2 times positive square root 2 is going to be negative 2 over 4 times 4 is 16. So 6 minus 2 is 4 over 16. So our answer is going to be 1/4. So our sine of 11 pi over 12 times our cosine of pi over 12 is going to equal 1/4. So in summary, we have our compound angle identities, which are all of these equations here. And then with our sine A plus B times sine A minus B and cosine A plus B times cosine A minus B. And then we also have another double angle identity, which we've learned, which is for tangent, where tangent of 2x equals 2 tangent of x over 1 minus tangent squared of x. That's all for this video. Thank you for watching.